Hi, this is Jeff from the Ozark Mountains in Missouri, USA. Well, this is the third episode of our series about the Convergent Workslate. You can see I've got it all back together here and almost got the microcassette working, and that'll be the first thing we take a look at in this episode. When we're done with that, we'll take a peek at these two accessories that the owner sent along with it and see what they do and see if we can make them work. Say, if you're a subscriber, thanks. I really appreciate it. It helps out a lot. If not, what the heck are you waiting for? If you look down below, you'll see a rectangular subscribe button. Click on that guy and you'll be subscribed. Then if you click on the bell-shaped icon, YouTube will be nice enough to let you know just as soon as I post a new video. Thanks. Well, let's get started. You might recall that one of the biggest problems that we had was that you couldn't easily get the cassette in and out because it wasn't pulling back the head mechanism far enough. Here is a picture of a head retract motor and the cassette mechanism. And here I've circled the two relevant bits, which is the cam on the head motor, which you see circled in red right there. And you see that kind of lobe-shaped piece, which is what actually pushes the head back. And on this other circled red bit, the little circular part at the 11 o'clock position is the cam follower that is on the arm that actually moves back. So whether by wear on the cam itself or the cam follower, the mechanism was not being pushed further enough back, so I decided I needed a spacer. So I set about to machine a piece of tubing with a 2mm inside diameter and 3mm outside diameter. And once I had the appropriate sized piece of tubing, I superglued that down into an aluminum block that had a groove the size of the outer diameter of the tubing. And this will allow me to hold the tubing in place while I cut it to size. So here we are starting the machining process, and I'm using a small bit. I think it was around 1/32 of an inch, which is 3/4 of a millimeter. So the basic idea here is I needed to machine the top half of the tubing away because I only need a semicircular piece, and then I need to cut two precise sections out of that. And here's the finished product. You see I've got two sections of brass tubing and a little bit left over on the end there. Now the trick is to separate my little pieces of brass tubing from the aluminum block, and fortunately acetone will dissolve the superglue, so the block just gets a bath in a little bottle of acetone. Let that set in there for an hour or so and the parts will be nicely separated. Here are the two sections of tubing all separated and ready to glue into the cassette mechanism. They are really tiny. And here we have one of the brass pieces glued onto the spare cassette mechanism. You can see that it could be a little wider and it was just a little too tall, so time for a second try. Most importantly though, is it did allow the cassette to go in and out properly. We're doing this handheld, so it's going to be a little shaky. I glued the second version of the spacer to the cam follower on the cassette mechanism and slipped a little wax paper under it so it wouldn't glue itself to the part below. And we'll let this set overnight. The inside diameter is just slightly over 2 millimeters. The outside diameter is 3 millimeters, so that leaves a 0.5 millimeter wall thickness. And it is slightly less than 3 millimeters tall, so it doesn't quite go to the top or bottom of the post, so we don't have to worry about it interfering. And I epoxied that in place with a dark gray epoxy, so that's why you kind of see what looks like a a dark line or gap there. That's just the epoxy color. This is the cassette mechanism that was in really bad shape. The first one that I did the machining on the pinch roller arm. Trying it out on here first to give you an idea of the scale of the spacer. That is it right there. Here we have the spare, quote unquote, cassette mechanism from the Workslate. This is the one I glued the spacer, or the shim, over the cam follower that pulls the pinch roller and the head mechanism back. And if you remember way back when I first did these videos, we found out that the gear on this mechanism, that the plastic gear that drives this cam, has a bad tooth. So it tends to get stuck in the all the way out position anyhow, which is kind of a benefit for what we're doing here. I've got my bench power supply set up at 3 volts, 600 milliamps, and it'll get stuck right where that bad tooth is, where this is just about as far out as it'll go now. You can see the tape actually will close down in there now. So, which is actually fantastic news. So now I'll pull the cassette mechanism back out of the good Workslate and glue the second shim into it, or epoxy it actually. And then we'll try adjusting the head and see what happens. Wasn't originally planning on recording today, which is one of the reasons I look a little rough. The main reason though is this. In the course of opening up a car door, I managed to smack myself in the head with it and put a gash right there on my eyebrow. Still not sure how I managed to do that, but sometimes things don't go as you plan. Another thing that didn't go as I planned was this Workslate, and we'll look at that in more detail later. But the point I wanted to make is sometimes stuff doesn't work the way you plan. And don't be afraid to just walk away, think about something else, do something else. You know, I finished my shopping trip I went to do, and I bashed myself in the head. Came home, ate some ice cream, took a nap, thought about things a little more, and I was able to find that error I made on this Workslate. It still doesn't work all the way. It's better than when I started, and you know, sometimes that's how it is. You can't always fix everything. Maybe if I had the schematics and some more experience working on these microcassette mechanisms, I could figure out how to adjust it. I don't know. But I sure gave it a good try, I think. I got the cassette mechanism installed back in here with the spacer on the cam follower epoxied into place, and you can insert and remove a cassette properly. However, it still doesn't read it. I even tried with reading the tape head directly with this VTVM, which is probably a 1960s, early 70s instrument that was designed for just that type of thing. And it was not sensitive enough to pick up anything unless I used the demagnetizer. Then it would just barely pick it up. So not sensitive enough for the job. So I thought, well, I'll go ahead and put this back together. And I got it back together, and it didn't work. And then it started squealing and making all sorts of funky noises, and I thought, oh God, I broke it. And took it back apart again, which is a pain in the butt, because getting this cassette mechanism in and out of the top cover is a pain. I've got this rag under the display just to protect it. I'm going to unplug that. This poor cable here for the display is falling apart. They never intended these to be unplugged and plugged back in multiple times. Okay. You see this clip here? If you refer back to one of the older videos, this holds a piece of insulated copper on the back of the board for RF shielding. I had, by mistake, put one in this area too, because I was installing these from the back, and from the back it looked like there had originally been one there. But there hadn't been, and it shorted out some traces right here, which are still intact, but I scraped them, and I'll go ahead and put a little solder on those. And just to make sure they're okay. But once the short was removed and that was cleaned up, it came back to life again. You know, still not reading the cassette, but what are you going to do? Okay, now when I was speaking earlier about taking a step back and taking a break and doing, just get away from a problem that's really driving you crazy, that's what I did, and I thought of another way to try to test my VTVM setup, trying to read directly from the tape head. Now, the problem with on the Workslate is it is an automatic control of the deck, and it only plays for a few seconds trying to look for a header. If it doesn't find it, it shuts it off. It also controls power to the amplifier, so it makes it rather difficult. So I've got the spare cassette deck here. So I've got an oscilloscope probe hooked up to one part of the head. That is hooked up to an old-fashioned VTVM that's made for this sort of purpose. It is on a 10 millivolt scale there. And right over there is, right here that is, our programmable power supply I have set to 1 volt output. If we go back down here and look at the tape, turn on the power supply, and I've got the head wound up against the tape, so this is approximately the speed that it would normally play the tape. So you can see it's moving, the head's up against it, the probe's hooked up, and we get bupkis on the VTVM. It's just not sensitive enough for this tape head. So outside of building a special preamp for this, I don't think there's much else I could do as far as trying to get the tape head aligned. So I got the little scratch that I put on the circuit board back here fixed, and I just spent like 15 minutes trying to figure out why it wouldn't come back on. I swapped the display from the other computer, etc. And then I remembered that the reset switch was on the bottom, and of course it was holding the reset switch in, so I propped this little screwdriver in here. And now it's saying how you haven't done anything for a minute. We're going to shut off. So I wanted to show you that the cassette will fit in here now. It'll not be any problem putting it in. And now it's rewinding. You probably can't see what it's doing all the way. And now it's playing, but it's not going to find anything. So mechanically, the cassette deck is okay. It works. Electrically, there is an issue, whether that is with the head itself, the electronics in this area where the amplifiers are, I don't know. I know the amplifier section here gets powered when it's supposed to, but I can't read any input to it, and I can't read any output from it. It just shut itself off automatically. So now I'm going to attempt to put this back into the lid here for the last time, hopefully. And then we'll get this back on its way to its owner. This is the original power adapter for the Workslate, but it's dead. It has the correct size end that fits the thing there, which is center negative. The barrel is positive, which is backwards of how it is today. And the problem is these things are glued or ultrasonically welded together. But if you look around the seam, sometimes you can get an indication of how it's put together. For instance, here where the cord goes in, I can see that just this part of the lip here is the top, but not the bottom of it. It's got this spudger set from Amazon to replace my broken one. Sometimes you can take a screwdriver handle like this, give that a sharp rap, okay, I managed to get this little prying device started in this corner. Now I'm just kind of working myself around. This one has been difficult. Normally once you get these covers started, they'll pop apart pretty easy. There we go. I think, oh my goodness. Oh, this wasn't much of a power supply, was it? It consists of a transformer, rectifier, and a diode. That is pretty sad. Bulge right here. I see some solder dripping there. I suspect that rectifier's measuring okay. I'm going to get you a close-up here. It's definitely got a bulge in the case. I think it's not actually that great in operation. Although it could just be that the cord was bad. We can test that easy enough. No, the cord's okay, so I definitely have a bad rectifier. Or a bad transformer, I guess. Half an ohm on the secondary. That seems rather small. What about the primary? Ah, primary is open. I suspect there is a thermal fuse under here, which opened up because the thing got too hot because the rectifier's failing because this power supply was a piece of crap. No, there is no primary fuse protection at all. This thing is not fused at all. Yeah, the primary's open. Well, somebody in Taiwan made this for Convergent back in the day, and it is pretty sad. So, I think we'll just put the cover back on it so the owner has it with the Convergent name on it, and we'll suggest that they use a modern replacement. First up here is this serial port and parallel port extension. It provides a Centronics parallel port, a DB25 serial port. It requires external power, and it connects to the Workslate through this RJ45 connection. This isn't Ethernet, it's just serial. It would plug in like so. And they put some nice big dip switches in here so you could change it to working as a serial interface or a parallel interface and set the baud rate, things like that. Here's a close-up of the label. Let's have a quick peek inside to see what's in there. Okay, just got 4 Phillips screws here. It's always exciting to watch somebody take screws out of a product. And okay, there we go. So we just have our dip switches here. A DC to DC converter type thing here, I'm guessing. LED is up on a big standoff here. Got some 7400 series logic. A couple Hitachi parts. HD63A01V1F. Got 2 of those. These are MC1488, MC1489. So a logic chip here and some op amps, transistors. And nothing on the back side, just a 2-sided board. And the capacitors on this actually look okay. And these are 74LS367AN. And two different crystals that are the same value, 4.9152 megahertz. To put this back together, hold that like that. Slip it down on there. You remember, on screws into plastic, you rotate it backwards till you hear it or feel it seat. Like that. That gets the threads that are already cut in the plastic lined up with the threads on the screw, so you're not cutting new threads and destroying the hole. Okay, well, there wasn't a whole lot in that, but they did a nice job with the layout on it. I like that. This RJ45 cable had some sort of weird coating on it that kind of turned to goo, and it smelled like smoke, but like fake smoke. It's kind of odd. And you might remember I said that there was a provision for a rechargeable battery pack, which is what this guy right here is. This is pretty dirty and crusty. It looks like it's just got 4 NiCad cells in it. Something about the size of AA's. I'll put that right back in its bag because that's yucky. Can be used as a reference for building a new pack, I suppose. Next up, we have the printer. It's got kind of a svelte look about it. It has a built-in caddy here for its RJ45 cable. It takes external power or batteries, which is kind of neat. There is the label for all of you label fans. And when I pop the top here, I bet several of you are going to recognize the mechanism that's in here. Get you closer up on that there. This has 4 little stubby pins down in there that rotate around. So it's actually a 4-color plotter. And this is the very same mechanism that was found in all sorts of printers back in the day, including the Commodore 1520. I brought this out because this is much more open and we can see what's going on here. So we've got the print head, and the print head goes to this side and it hits a little pawl that's down here, which rotates the pins around. And there is a micro switch in here that it hits when it's at the black pin, I believe. And it can come down to this side and goes under this pin, and you can use that to flip it out and get the ink pen out. And this bar across the back here will push the pin into the paper or not. And we've got a solenoid down here and this arm, and I'm mentioning this explicitly because that's broken on the one for the Workslate. So we might have a look at that. I'm guessing that piece of plastic is broken though, so we won't be able to fix it. Typically on these, there are problems with these little gears breaking because the plastic shrinks with time, and of course the steel doesn't, so the plastic will crack. Okay, here is our printer. I think when you get that extra pin out of there, the owner of this also had a tube of black pins and a tube of colored pins, but sadly these are all dried out. I don't know if they can be rejuvenated or not. We'll back the roll of paper out of there. You even had an extra roll of paper. And take out the batteries I put in there to test it with. This has 1, 2, 3, 4, 5. I'm sure these ones toward the corners hold the case together. This may or may not be involved. It might hold part of the mechanism in place, so we'll save it for last. I always like making sure all these screws are the same length. Yeah, it looks like they are going to be the same length. Really nice. Okay. Nope. Okay, this one is involved. Sometimes you'll have and it's the same length. Sometimes you'll have a screw toward the center of something that holds part of the mechanism to the bottom case. And it just makes it messier to take it out. Well, that was fairly simple. Oh, I didn't notice before, there's actually instructions written on the inside of the lid right there. You could probably just see that if I move it around. Let's see if I can get you zoomed in here on this part of the mechanism. Okay, yeah. So we've got this little arm here, which should be connected to this plate, and it's not. So it looks like that solenoid is okay. But, yeah, that arm is broken. So that's not going to work. Those are made out of nylon, which you can't really glue. But this is the same Alps mechanism that is in the Commodore 1520 printer. Atari had one, Radio Shack had one. I think everybody and their brother used the same mechanism. Okay, see what else there is to see here. So this is the only bit of a power supply, which really just looks like a big honking capacitor, a couple small capacitors, and a ribbon cable here that goes up to the circuit board. Lots of copper shielding. Sometimes people today mistake all this shielding, metal foil and stuff like that you see in older equipment, as that the FCC requirements were worse back in the day, which isn't the case. Now manufacturers are able to do stuff like put a metallized coating on the inside of the case itself, which is less expensive and less of a hassle. Or they can design and simulate the circuit board in such a way to eliminate the noise problem to begin with, or the parts of the circuitry that created most of the noise are combined onto one chip now, which helps eliminate that problem. So here's our switches here. That's what that cutout in the foil was for. It was for the switches. And we have a screw here. Now that's a grounding tab for the printer mechanism there. Well, that is sort of connected there, so I'm not going to pull it all the way out. Okay, that's not too bad. So here we've got a couple more Hitachi chips. An HD63A01V1F. And this one does not look like Hitachi. A DLG1702E. This is just 7400 series logic. The caps look okay on this board. Not the devastation we had on the main board. This chip here, if you can just see it, is an LB1247. Got a crystal there, but this is not showing on the side where I can tell you what value it is. So they just made a nice compact circuit board there, didn't they? A lot of surface mount stuff for the day it was built in. Component labels on the silk screen didn't come out real good though. All in all, I'd say they did a nice job. There we go. And just, again, what happens is the plastic continuously shrinks as it ages, very, very, very slowly. And if it is molded onto a metal shaft or pressed onto a metal shaft, of course the metal's not going to shrink as it ages, and the plastic does, and eventually the plastic will crack. But you know, they didn't build this thing to last 40 years, so it's done pretty good. Well, I hope you've enjoyed this series on the Convergent Workslate. It certainly is an interesting computer, and it had a lot of good ideas. Unfortunately, I think they kind of missed the mark with making it a spreadsheet-only type computer, which really limited its market. While stylish, the keyboard is rather useless for typing on, but there was a lot of other things included, such as answering machine functionality and being able to save voice notes along with your data. That was pretty clever. In the next 2 episodes, we'll take a look at a Panasonic color dot matrix printer from the late 80s, early 90s, and see how many different computers we can get that working on, everything from modern Windows to an old Commodore 64. Also, we'll start a series on an open source DRAM tester for these old computers. If you have any questions or suggestions, just leave them in the comments down below. I would love to hear from you. And if you'd like to help support the channel, look in the description down below for the link to my Subscribestar account. It's sort of like Patreon. Make sure you click that subscribe button and then click the bell so you're notified just as soon as I post a new video. Thanks. Until next time, bye.